When we're looking at relations, we're looking at some relations which are linear, which are a straight line, and we're looking at some that are nonlinear, which are curved. So I'm going to give you an example of two nonlinear relations. So this is called a quadratic relation. It's indicated by this square. And when we graph these quadratic relations, we should see if we can use its symmetry. So where would this be symmetrical? When we square negatives, we get the same answers as if we square positives. And so the middle of that symmetry would be where the transition is between positive and negative, which is 0. So when we graph this, we really should use a 0x, and that is going to indicate the point of symmetry. So when I square this, I'm going to end up with 0 squared times negative 1/2 plus 4. So there's going to be one coordinate. I can plug in another value, let's say x equals 1. And I'm going to use a symmetrical point negative 1. When I do that, I end up with negative 1/2 plus 4, so that's 3.5. If I plug in negative 2 and positive 2, I'm going to end up with 0. Okay, and then notice that there's some symmetry going on here. So here I'm going to have 3.5, 3.5. Here I'm going to hit 0, hit 0. And the shape of this graph ends up being something called a parabola. It kind of looks like that. I could plug in a couple more coordinates, and the more symmetrical that I make my points, the easier it is to graph. So it's important that when we graph these, that we can recognize where the middle is, and that allows us to draw this symmetrically. This is another example of a nonlinear relation. This is an exponential function. And an exponential function grows by multiplying by 2. So this is going to grow by double, 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 double. So what does this look like? Okay, so I'm going to start maybe at x equals 0 and see what happens. I'm going to get negative 0 to the power 2 to the power 0, which is 1, minus 3 is negative 2. So I'm going to end up here at negative 2. And as I plug in points, 1, I'm going to times by 2, so it's going to be negative 1. 2 squared minus 3 is 1. I'm going to end up with 2 to the power 3 is 8, minus 3 is 5. So I'm going to end up at y equals 5. And so what's happening here? Well, as I go into my negatives, this is my positive. It's going to kind of start shooting off. If I start going into negatives, what that means is negative power means dividing. So this is just going to get smaller and smaller and smaller and smaller and smaller. And we're essentially going to end up at negative 3. So if I plot some points here, I'm going to end up kind of here. It's just going to get closer and closer to negative 3. And we end up with what we call a horizontal asymptote at negative 3. It's just going to keep going down, down, but it's never going to get below negative 3. Okay, this term is never going to be negative. So that means that we're always adding on to negative 3. So we're always going to stay on the positive side of negative 3. And we end up with this exponential curve. So this is a new function, and we want to start getting familiar with more functions, as many functions as we can, because that allows us to understand math from a graphical perspective. And this is what we're going to start doing in more in grade 11, in grade 12, and calculus. It's all about understanding math from a graphical perspective.